So welcome back to this new video. In this video I'll try to explain you what is semaphore and what is their buffer bound problem, also known as producer consumer problem. So in this case, try to imagine there is a producer, an entity, and another entity or processee is a consumer, and in between they have a finite sized buffer which they are mutually sharing. So there should be mutual exclusion, right? Otherwise there would be a rat race. That's called rat race or rat race condition. I don't know what's that thing called. Let me just check. What is that thing? What is the thing again? Whatever that thing is. Okay. Yeah, race condition. Whatever, at race condition or whatever race condition. So what you're gonna do here, this is a classic synchronization problem. In this case you can solve this using two-step semaphore approach. Semaphores are basically synchronization tools, or we can simply call them variables, which could be used to address this problem with a solution. Initially we will set these semaphores. Let me just define the semaphore first of all. There are three semaphores: filled, or you can call it full, empty, and the third is mutex. Mutex, M-U-T-E-X. M-U-T means mutual, E-X, the last is exclusion. We set mutex, this variable, to equal to 1, that is true. And other things like filled, so what do you want? The slots to be filled? No, right? Initially the slots are not filled. So we type full, F-U-L-L, full, or you can use a variable fill. I prefer full because it's a semaphore, so there should be standard. Let's call it full. Full is set to equal to, as I told you, 0, and empty. Empty should be equal to the size of the finite buffer. Let's call it buffer. For example, a buffer is an array, let's call it buffer.length. Okay. Anyway, so what we're gonna do right now, so let's say in the producer case, so first of all, before generating, we have to make sure we have to write wait, and in the brackets we're gonna type wait for empty slots. So if this is true, then it will go to the other thing, that is what is the other thing? That is wait for the mutex. Mutex is basically gonna make sure that there is mutual exclusion, that is you can safely perform your operation. There is not like a rat race happening. So there is a no race condition, like I'm gonna access the buffer right now, the producer is saying, or other time the consumer, like I'm gonna access the buffer right now. So like there is no race condition. How to do that? You can using mutex. So as I told you, wait mutex. So as you have acquired the mutex, that is your mutex for your producer is true, then you can move to push that very produced item into the empty slot. Okay, then after that, what you do, since it is an empty slot and everything is going crazy good and everything is like happy, then what you do, you release the mutex, right? Since you have injected your data into this buffer, now you're going to release the mutex. How do you do that? You type signal, and in brackets you type in how do you type in fill? Oh, in the signal mutex, you release the mutex, and after that you give a signal that there is an empty slot. So you get a signal, you type in empty. Oh, you signal, you type it full, not empty. Signal full, right? You just filled damn slot in the buffer, which was initially empty in our case. Then we go to the, sorry, it's getting lengthier. Then we go to the consumer side, and we just wait for an empty. We wait for a filled, like we type in wait, and in bracket we type in fill. Then we acquire the mutex. How do we acquire? Wait, and in bracket we type in mutex, and since already mutex has been released, so in your case it can be like true. It's already be signaled from the producer side that it is free. And after that, what you do, remove the item from the very buffer slot, and then you signal your mutex or release your mutex, and you give a signal that there is an empty slot, like that. So you continue the process. So this is a synchronization problem, so it will like infinitely happen. So in the code, if you look the pseudocode which is given, there is a do while loop, and in the while condition there is no set limit, it's always set to true. So both of this process will continuously happen. I think that's all for producer consumer problem. And there is a pseudocode for that. It's just like we set an item every time using a function, we invoke that function, and that item is created, and we check for if there is an empty slot, and then we acquire the mutex, and at the same time we push that item using the square brackets at a variable called in, at an index basically. We push that item at that index, and after that we update the index by setting in is equals to in plus 1 modulus buffer dot length, and it sounds complicated. And then we release the buffer as I release the mutex by typing, sorry it's getting very long, by releasing the mutex. How do we release the mutex? By typing signal mutex and signal that there is a fill slot. So we type in release fill, and this do while thing keeps on happening. This is the producer side. Consumer side, it will be just opposite, that it will check for if there is an empty slot, wait or not empty slot, filled slot, wait filled, and then it's gonna check for mutex, that will wait mutex, and you acquire the mutex, and then basically it just removes the very item at the place. So basically consumes that information, processes that information, whatever the fuck it wants to do, it does with it, and then it releases the mutex, and yeah, something like that. And that's all for the video. Hopefully it makes a bit of sense, right? Yeah, it does.